Good evening, dear ladies and gentlemen. Today I'm going to talk about Mars exploration and about one particular mission that is called InSight. InSight, which stands short for Interior Exploration Using Seismic Investigations, Geodesy and Heat Transport, is a Mars lander that was designed to give the red planet its first thorough checkup since it was formed 4.5 billion years ago. It is the first outer space robotic explorer that is going to study in depth the inner space of Mars, that is, its crust, mantle, and core. And on the 26th of November 2018, that is a bit more than a week ago, InSight successfully touched down on the red planet after an almost 7-month 300 million mile journey from Earth. InSight landed on Mars on the 26th of November 2018 at 11:52 a.m. The entry, descent and landing, or the EDL, phase began when the spacecraft reached the Martian atmosphere, that is about 80 miles from the surface of the planet, and ended with the lander safe and sound on the surface of the red planet 6 minutes later. For InSight, this phase included a combination of different technologies that were inherited from the past NASA Mars missions, such as the Phoenix Mars lander. The light landing hardware helped InSight to place a higher ratio of scientific instruments and tools compared to the total mass of the lander on the surface of Mars. Compared with the previous landers, such as Phoenix, InSight's landing presented 4 additional challenges. First of all, it entered the atmosphere at a lower velocity, at about 12,300 miles per hour versus 12,500 miles per hour for Phoenix. InSight also had more mass entering the atmosphere, about 1,340 pounds versus 1,263 pounds for Phoenix. InSight landed at an elevation of about 4,900 feet, higher than Phoenix did, so it had less atmosphere to use for its deceleration. InSight landed during the Northern Hemisphere autumn on Mars. That is when dust storms are known to have grown to really big proportions. Besides, InSight presented certain improvements as compared to Phoenix. It used a thicker heat shield, partly to handle the possibility of being sandblasted by a dust storm, and it used special parachute suspension lines that were made of stronger material. The entry, descent, and landing sequence of the lander broke into 3 parts. The entry, that is when the spacecraft was controlled by small rockets during the descent through the atmosphere towards the surface. The parachute descent, when the InSight spacecraft slowed using a larger parachute and extended its 3 shock-absorbing legs. And the last stage of the descent process, the power descent, that is when the lander separated from its parachute, its 12 descent engines on the land began firing, and special onboard software slowed down the spacecraft until touchdown. The lander uses special, very modern equipment and instruments that are going to help it to delve deep beneath the surface of Mars and seek the processes that formed the red planet. It is going to do so by measuring the vital signs of the planet, that is, its pulse or seismology, temperature, the heat flow, and reflexes, the precision tracking. This mission is part of NASA's Discovery program for highly focused science missions that ask critical questions about the solar system. To understand how rocky planets are formed and how they evolve, InSight will study the interior structure and the processes of Mars by determining firstly what is inside the planet and secondly by studying Mars' tectonic activity. The size of the core of the planet, what it is made of, and whether it is liquid or solid inside. The thickness and the structure of the crust will be studied too, together with those of the mantle, and then the lander will also measure how warm the interior is and how much heat is still flowing through the core of the planet. Besides, InSight will figure out how tectonically active Mars is today and how often meteorites impact it. For this, it is going to measure how powerful and frequent the seismic activity of the planet is and where it is located within the structure of the planet. Besides, it's going to assess how often meteorites impact the surface of Mars. So, after this rather detailed and technical description of the InSight mission, you might ask the question why we need to study Mars. Previous missions to Mars have investigated the surface history of the red planet, examining such features as canyons, volcanoes, rocks, and soil. However, the signatures of the planet's formation can only be found by studying the vital signs and the interior of the planet. In comparison to the other terrestrial planets, Mars is not big or small. That means that it preserves a very good record of its formation and thus can give us insight into how terrestrial planets are formed. So it is a perfect laboratory from which to study the formation and evolution of rocky planets. Studying Mars' interior structure answers key questions about the early formation of rocky planets in our inner solar system, such as Mercury, Venus, Earth, and Mars. They were formed more than 4 billion years ago, and they are known as rocky exoplanets. And of all exoplanets of this type, besides the Earth, Mars is of particular interest to our human scientists. Some, though, may be skeptical about the value of such lengthy and costly research. Why should we study Mars when there is still so much to be studied on Earth? The answer lies in the fact that the two planets are very similar, yet different in important ways. Quite simply, studying Mars can also teach us a lot of things about the Earth. Mars, like Earth, has an atmosphere, it has winds, clouds, weather, and dust storms. It has massive volcanoes, great rift valleys, dry river channels, and huge sand seas. Mars has polar ice caps, snow banks, and glaciers which are strikingly similar to those which we can find here on Earth. And most importantly, Mars has evidence for liquid water and habitable environments, both in its past and in its present. The variety of landforms and processes and environments by themselves make Mars a very interesting thing to study, but the most compelling reason to do this is not necessarily because it is similar to the Earth, but it rather lies in the differences with our planet that will help us to better understand Earth and its history and evolution. We can ask such questions as why is the current climate of Mars so cold and dry, different from that of the Earth? Why have the climates of the two planets diverged over time? What processes have led to those differences? And what can we learn about the possible future changes in our own climate from studying Mars? Probably the most fundamental insight that will come from comparing Mars to the Earth is the understanding that we'll gain about how life emerged on our planet and what conditions were essential to its origins. Water, for instance, is one of the key necessities for life, and the evidence for water in the early history of Mars has been discovered numerous times over the past decades. We have found mineral evidence for ancient hot springs on Mars, similar to those that are found today in the Yellowstone National Park, massive salt deposits that formed when the lakes of salty water evaporated, sediments in freshwater streams and delta, and so on. Each of these ancient water environments would have provided life with a different habitat in which to develop. And such a big diversity of ancient environments on Mars provides us with the opportunity to determine which of the early environments may have been the most conducive to the life's origin. Over the time, we have come to realize that anticipating the Earth's future will require a deeper understanding of the complex play between the surface, interior, atmosphere, hydrosphere, and biosphere. And comparing and contrasting those systems with those of other planets will lead to a better understanding of how they work and how their different components interact. The closer the similarity, the more useful the comparison, and the deeper the insight. Mars, which is remarkably similar to Earth, will thus provide us with clues to study our Earth history. Thank you for your attention.